So the next concept that we're going to discuss is EC2. That stands for Elastic Compute Cloud. So I'm going to just jot down some important points and then you can just make a note of them. So EC2 stands for Elastic Compute Cloud. Elastic Compute Cloud. Now what's exactly this is? So this is a service that provides scalable compute capacity in the cloud. So what do you mean by this scalable compute capacity? I just discussed this concept with you in detail so that you understand this important point. Let's imagine this is the AWS cloud. Right? This is the Amazon Web Services cloud. And I'm talking at the networking level. Let's imagine this is a small VM. It stands for virtual machine. You might have heard about it, or maybe you might have used it. Virtual machine, which means it is not physical in nature. Okay? Slash, it's called a virtual server. It's called a virtual server. However, Amazon will not call it as an VM. For them, it is simply an EC2 instance. Now, generally we use the term instance. The right term is the EC2 instance, but the thing is that instance is easy to pronounce as compared to the complete EC2 instance stuff. So whether it's EC2 instance or instance is the same thing. Fine. Now, this EC2 instance or a virtual machine or a virtual server will have some compute capacity. Examples. The examples are, it will give you a certain amount of RAM, virtual CPU, storage, GPU. So it will give you some compute capacity. Now, this compute capacity is scalable, which means that you can increase or decrease it. With few simple clicks, you can increase or decrease the compute capacity of the instance. You can increase or decrease the compute capacity of the instance. You can change its RAM, its CPU, storage. You can, for example, you have one virtual machine. You can make it as 10 virtual machines of the same capacity. So it is quite flexible in nature. You can have as much or as little as you need. It gives you the scalable compute capacity in the cloud. What's that? It gives you the scalable compute capacity in the cloud. Fine. Now, this virtual machine, I'm talking about from the compute perspective, you can change the compute attributes. Upon this virtual machine, you deploy a lot of things. So let me just take the same cloud. It is the same Amazon Web Services cloud, and this is my EC2 instance. In the short form, I will just write it down as EC2. Now, upon this EC2, what you do next is that you install a lot many things. For example, you install the operating system. In the short form, I just write it down as OS. OS can be either the Linux or Windows. Okay, plus applications, plus services, plus softwares, plus scripts. Basically, you install everything upon this instance. You install everything upon the instance. Fine. The question really is, that if you can install everything upon the instance, how exactly you do it? Basically, what you do is that you make use of a concept called AMI, which stands for Amazon Machine Image. Okay. Now, this Amazon Machine Image, what is that? It's a pre-configured template. It's a pre-configured template which consists of everything. What is that? Operating system, either it can be Linux / Windows. It consists of the applications, services, softwares, and scripts. You bundle everything as a single package. Or a template. Right? Now, the thing is that you execute these templates, these packages, and you install everything upon the instance. For example, what you can do is that I just give you a few examples right now. And of course, once we start deploying this stuff, I'll show you one by one. For example, this is my, let's take some other color. So let's imagine this is my EC2 instance. Fine. Now, the thing is that upon this instance, I want to deploy the Ubuntu as an operating system, Ubuntu 16.04. Fine. Plus, I want to deploy a MySQL database. Plus, I want to deploy upon it the WordPress blog, a site. Okay. So the thing is that I encapsulate in the form of, for example, a customized AMI. Right? I encapsulate it in a single package. For example, so I just encapsulate as a single package and install everything upon the instance. Fine. It's a package. It's a package that you execute and install everything upon the instance, including the operating system, the services, applications, softwares, and even the scripts upon the instance. So you need to have the AMI. Basically, what you do is that if you have one AMI, you can launch any number of instances of any type. You can launch any number of instances. You have a single image. For example, if I give you an operating system, a Windows operating system in the form of a disk, a CD-ROM, a disk, or external hard drive, the same operating system can be installed on multiple machines. I can have a copy of an image, a Windows operating system, and it can be installed upon multiple machines or multiple computers. The same thing applies over here. You have the same customized AMI, which consists of the customized scripts, softwares, applications, services, and scripts. You take that AMI, you can install all these things on any number of instances, 100,000, 10,000, there's no limit of any type. Now, what do you mean by any type? Basically, the next thing I'm going to discuss with you is the third component I discussed with you. The third concept is called the instance type. Fine. Now, instance type is the underlying representation of instance physical resources. Okay. For example, virtual CPU, RAM, storage, GPUs, graphical processing units, etc. For example, you want to buy a laptop, a computer. You go to the Best Buy store, and what do you see in the laptop or the computer? You want to see exactly the storage, RAM, CPU, depending upon your needs, your requirements, right? If you want to store a lot of content, you will go for a lot of, I would say for a big hard disk, maybe 2 terabytes, 4 terabytes. You want to run a lot of processes, then you want to go for a bigger RAM, a higher amount of RAM, maybe 16 gig, 24 gig. So the thing is that depending upon what type of application services you'll be running upon the instances, depending upon what type of applications or services you would be running upon the instances, you carefully choose the instance type. So that is very important. Okay. Now, in a free tier account, we're going to discuss that in detail afterwards. In a free tier account, you get T2.micro as instance type for free of cost. This gives you 1 gig of RAM, okay, and 1 virtual CPU. 1 gig of RAM and 1 virtual CPU. So this is the only instance type that you get in a free tier account. Now, as we discuss the theory, just after discussing the theory, I show you the demo. There I'll show you exactly that how you choose instance type, right? So what we discussed as of now, we discussed the concept of EC2, the staff elastic compute cloud. It gives you the scalable compute capacity in the cloud. You launch the virtual machines using this service, which gives you certain amount of compute capacity. You can increase it or decrease it, or you can increase or decrease the number of instances. Then you want to install the operating system, applications, services, softwares, scripts upon instances, right? You want to install everything upon it. But basically, the question really is that what exactly determines that how these things will be installed? You encapsulate everything in the form of the AMI, that stands for Amazon Machine Image. It's a pre-configured template. It's a pre-configured template that consists of the operating system, which includes Linux and Windows, applications, services, softwares, and scripts. You bundle that in a single package in the form of a template, and you install everything upon the instance. If you manufacture a customized image or the AMI, you can launch any number of instances through it of any type. So what's instance type? It's the underlying representation of the instance's physical resources. For example, it depicts the amount of RAM, CPU, storage, GPUs that instance will offer to you. In a free tier account, you get only one instance type. That's the T2.micro, which gives you 1 gig of RAM, and also it gives you 1 virtual CPU. Fine. So that's the concept of instance type. The next concept that we shall discuss is, the fourth concept is, we'll discuss the concept of VPC, or I would say let's discuss the IP addresses first. What is that? IP addresses. See, why your server needs IP address? To enable communication. It enables the communication on the network. Your machines or the servers need the IP addresses. Even you have joined this session using a computer or laptop, it's getting an IP address. That's why it's a part of the biggest public network, that's the internet. If your machine is not getting any IP address, it's a standalone machine. If your machine is not connected to the internet, it's a standalone machine. So in order to make that laptop, computer, server, machine, virtual server, or an EC2 instance that should be the part of a network. If you want to make it a part of a network, you should be assigning an IP address to that physical server or the virtual server. So if you want to make a physical server or a virtual server be a part of a network, it should be assigned an IP address. Okay. Now the thing is that there are multiple categories of the IP addresses. I just elaborate right now, but we'll just discuss in detail afterwards. The first category of the IP address is the private IP address. What's that? It's the private IP address. I'll just elaborate some of the features of it. First one is that it enables internal communication only. It enables the internal communication only. Okay. Basically, if the machines are in the same network, if I say internal communication on the same network, then you make use of the private IP addresses. Fine. And the thing is that they're defined by some ranges. What are the ranges of them? They're defined by the particular ranges. The ranges are the following: 10.x.x.x.x, 172.16.x.x, it will go up to 172.31.x.x. Okay. And the other category that we have is 192.168.x.x. Okay. Over here, X denotes any number between 0 to 255. X denotes any number between 0 to 255. Fine. So the main purpose of the private IP address is that it enables the internal communication. That's the main purpose of it. That's the main intent of it. Fine. That's the main intent of it. So you make use of the private IP addresses. It enables the internal communication, which means that it happens on the same network. And these are the different range of IP addresses being assigned to the instances on the same network. That's the main purpose of it. That's the main intent of it. Now, the next question really is, who assigns them? Who on the earth assigns them? Who assigns the private IP addresses? It is the customer who assigns the private IP addresses to the resources. Customer is the one that assigns and manages these private IP addresses. Fine. We're going to elaborate that on in detail afterwards, but as of now, you have to understand this concept. Now, also, every EC2 instance should get a private IP address. Every instance should get a private IP address. This is mandatory. You can't have any server running on the cloud which doesn't have any IP address. Private IP address is mandatory. Every instance should have that. And also, it is static in nature. This means that it will not change. It will not change. So if any instance has a private IP address, it will not change. Fine. So these are some of the basic things. The next thing that you have to understand is the next concept or the next type of IP address that I'll discuss with you is the public IP address. What is that? That's a public IP address. This is used for external communication. That's used for external communication. And the next thing that you have to understand is that basically the thing is that if you want your machine to be accessed, or your virtual machine to be accessed by the internet, it's used for I would say it is used for external or internet communication. External or internet communication. The next thing that I will discuss with you is that what are the different type of ranges that are applied to this thing. So what are the ranges? So if you talk about the ranges, it is any range except the private IP address range. Okay, except the private IP. And the second one is the loop back IP. What's that? It's a loop back IP, which is 127.0.0.1. Basically, this is used for troubleshooting. Except these two IPs, any IP can be a public IP. The private IP and the loopback IP, which is used for troubleshooting. So the thing is that it is used for troubleshooting. So you have to understand one thing, that you can't use any one of these two IPs as the public IPs. So a public IP can be anything except these two different types of IP address ranges. Okay. Now, the next question really is that who assigns them? First one is AWS. There's no charge for it. They will not charge for you. Even private IP is free of cost. So who assigns them? AWS. So even for the private IPs, if you just go back, let me just, for the private IPs, if you just, it's free of cost. It is free. Even the public IPs are free of cost. There's no charge. Optionally, you can bring your own IP. Okay, where you lease out public IPs from ISPs like Tata Telecommunications, Reliance Info. You lease out the IPs from them and then you migrate them to the AWS. So who assigns them? AWS or the customer? But of course, in this case, you have to. This is paid. If you bring your own IP, if you lease them out from the service provider, then you have to pay for that. Because, for example, I lease out some public IPs from Airtel Communications. They will say, okay, you have to pay $100 for a set of, let's suppose, 500 public IPs. So I have to pay to them, and then I migrate them to AWS. Fine. And also they are static in nature. I'm sorry, they are not static. They are dynamic in nature. This means that they will change depending upon the state of the internet. What do you mean by dynamic? I'll elaborate that in detail afterwards. They will change depending on the state of the instance. They will change depending upon the state of the instance. It's dynamic in nature. So these are two different types of IPs we discussed: the private IP and the public IP. Of course, I will just give you the link to access these notes. You can see them in your free time. The third category of the IPs we discuss in brief, not in detail, because we'll discuss them in detail afterwards, not right now. It's the elastic IPs. What's that? Because once we discuss the VPCs, I discuss or elaborate the elastic IPs for you. So if you talk about the elastic IPs, they are same as public IPs. What are they? They are same as public IPs. They're same as public IPs. They're used for external communication. They're used for external communication. Fine. And so what's the advantage that you get over the public IPs? They are static in nature. They are static in nature, which means that they do not depend on the state of instance. Okay? And who assigns them? That's the next question. It's the customer who assigns them. Who assigns them? That's the customer. The answer is customer. Okay. What about pricing? You get 5 EIPs, elastic IPs per region for free. And that's the maximum limit you can consume. Okay. I'll elaborate these points in detail. Right now, just get the concepts first, then we'll elaborate all the points. It's free of cost, it's maximum limit. However, there are 2 conditions. So that they remain free. That is, elastic IPs or EIPs should not be assigned to stopped instances. So instances should not be stopped for longer duration. And also EIPs should not be sitting idle. They should be assigned to an instance. Okay. I elaborate these points in detail afterwards, not right now. So elastic IPs should not be assigned to the stopped instances, and they should not be sitting idle. Fine. That's the main concept of elastic IPs. So these are 3 different types of elastic IPs that we discuss, that we use in the AWS environment. Okay. The next concept that I discussed with you is the VPC. What's a VPC? So this is the 5th concept. VPC, or it is the virtual private cloud. Now we'll discuss this thing in detail in one of the upcoming sessions. There's a complete 4-hour lecture on the VPC, because as an architect, you should be proficient in designing the VPC. So we should discuss exactly that, how you manufacture the VPC in detail afterwards, because it's very, very important that you understand the concept of VPCs and how exactly they are useful. So what's a VPC? Why do you need it? And what's the purpose of it? See, the VPC or the virtual private cloud, the main concept is that it is a virtual data center. It's a virtual data center that you deploy upon the cloud. Okay. It gives you a lot of security. Fine. It gives you flexibility. These are the benefits. And transparency. It gives you a lot of security, flexibility, and transparency. That's what it does. Fine. So it's a kind of a virtual data center. It's a kind of a virtual data center that you deploy upon the cloud. Now, the next thing comes in that, okay, if that's the case, how exactly they are being used and how you structure them. I give you a very brief overview, and once we move forward, of course, I'll discuss all the details with you one by one. So let's take or let's draw one thing, and I just try to explain you the stuff. Just pay attention and understand exactly the essence or the concept of the VPC. So let's imagine this is my VPC, right? Now the thing is that VPC is deployed in a single region, that's Mumbai. Okay, and you assign them an IP address. Basically, we call it as a CIDR block. CIDR block. CIDR stands for classless inter-domain routing. Fine. So we assign a CIDR block, like for example 10.0.0.0/16. It's one of the private IP address ranges. Now I discussed with you what this /16 means afterwards. So basically we assign a private IP address to structure the VPC. Now in the VPC you carve out different subnets. What's that? What's that? It's the subnets. Fine. So we label it as, for example, this is the subnet A, this is subnet B. Okay. What's a subnet, by the way? It's a complete block. It's a complete block of private IPs. That's what a subnet is. It's a complete block of private IPs. So for example, this subnet has a range of 10.0.1.0/24, and this one has 10.0.2.0/24. Now how this slashes make a sense, I'll discuss that afterwards. But right now you have to understand is that these are the private blocks. These are the private IP addresses, or the block of private IP addresses. And each subnet is linked to a specific AZ. It is linked to a specific AZ. Now, what we do is that we deploy our instances in these subnets. For example, this is my instance A, this is my instance B. We deploy. So what are these? These are my instances, or I would say EC2 instances. So if you see from networking perspective, you deploy or launch your instances inside these subnets, which are associated to different AZs. Okay. Now these instances will fetch their private IPs from subnet range. Okay, so the thing is that, let me write down some of the colors so that there's no confusion over here. Each of these instances will fetch the private IPs from the range of the subnet. So let me write down. So these EC2 instances will inherit / fetch private IPs from the subnet range. So depending upon what's the range assigned to the subnet, these instances will get their private IPs. For example, this instance can get 10, let's write it down, 10.0.1.1/32. This instance can get the private IP address from this range, 10.0.2.2/32. So these instances will inherit or get the private IP address from the range of the subnets they're launched into. Fine. And optionally, you can assign them the public IPs. For example, I assign a public IP to the instance B, 54.72.82.108/22. I'm just giving you one example. So you can optionally you can assign the public IPs to them. Fine. So what's the crux of the story? Every instance will get the private IP. Every single instance will get the private IP, because those instances are launched inside the subnet, and each one of those subnets will have the private IP address range, and the instances will inherit or fetch the IP addresses from the range of the subnets they are launched into. From the range of the subnets they have been launched into. And optionally, you can allocate the public IPs to them, or the elastic IPs. It is the same thing. It's with small differences. Either you can assign the public IPs or the elastic IPs. In the short form, it's EIPs. Fine. This is the essence of VPC. A brief introduction to the VPC. In the future, there's a 4-hour lecture where I elaborate all different components of the VPC in detail. Right? Right now, what you have to understand is the concept of VPC. It's nothing but it's a virtual data center, which gives you a ton of security, flexibility, and transparency. You structure the VPC you lay out a VPC in a region, you carve out the subnets from that VPC, and you launch instances in those subnets. The subnets are linked to a specific AZ, and the instances will inherit the private IP from the range of that subnet. Optionally, you can assign the public IPs to the instances. Fine. So, in a nutshell, if you want to label it, if for the EC2 instance, if I launch an EC2 instance in a VPC, who assigns the private IP, or how it gets the private IP? It fetches from the subnet range. Okay, and that subnet range is defined by VPC range. And who defines the VPC range? The customer. So at the end, or indirectly, you are the one who defines the private IPs. Okay, you assign the private IPs to the VPC, then to the subnet, and instance will get their private IPs from the subnet range. Fine. And what about the public/elastic IPs? Who assigns them? The customer. And these are optional. Fine. And this is mandatory. Fine. So that's how you differentiate between the public IPs and the elastic IPs. It is extremely important that you understand this concept, because once you move forward, you have to understand this concept. Now, even though this shall be discussed in the future in detail, it's extremely important that you understand this concept in brief right now, because when you deploy the instance, it is very, very important that you have to apply the VPC and the subnet in that process when you launch the instance. That's why I have to discuss in brief right now, because I'll show you once you launch the instance, then you have to choose a VPC and the subnet of that instance. Okay, so that's the fifth concept that we've discussed. That's the VPC. Okay, the next concept that we'll discuss is the sixth concept. Is the tenancy. Okay, what's the tenancy? It defines how virtual machine slash EC2 instance occupies a physical machine. See, right now we're talking at the hardware level. These virtual machines, I'm talking at the hardware level, are launched on a physical server. Now, the thing is that they use a concept called virtualization. You may have heard about it, you may have used it, virtualization. Virtualization means that you take the same physical server, okay? It can be, for example, HP, IBM, or a Dell physical server, okay? You install upon it a client software that's called a hypervisor. It's a layer. What's that? It's a hypervisor. For examples, for the VMware, we use VMware ESXi. Okay, VMware ESXi. Microsoft uses Hyper-V. And AWS uses the Zen hypervisor. So in AWS, the hypervisor that we use is the Zen. Now, what happens is, why we install the hypervisor? Because on the same physical machine, we want to deploy small virtual machines. What are these? These are, let me just make it more clear. These are virtual machines or VMs. These are virtual machines or VMs. Now, upon these virtual machines, you deploy different types of operating systems. For example, upon this virtual machine, I can deploy a Windows 2008 server. Upon it, I can deploy Windows 2012 server. Upon it, I can deploy Red Hat Linux Enterprise operating system. Upon this, I can deploy, let's imagine the Amazon Linux operating system. And upon these operating systems, I can deploy different application services. The concept of virtualization is that you can make the best use of a single physical server, upon which you deploy multiple virtual machines. And upon those virtual machines, you deploy different operating systems and different applications and services. Fine. Now, virtualization is the backbone of cloud computing, because nowadays cloud computing is well adopted, because virtualization it's making the things happen for us. I would say this is what empowers the cloud computing. Okay. Now, AWS, this is called tenancy. This is tenancy because on a single physical server, multiple virtual servers are running. Okay. Now, what AWS says is that we give you instance isolation. We install some firewall on a physical machine, and we give you something called instance isolation. What do you mean by instance isolation? This means that, okay, if I label these instances A, B, C, D, by default, they can't communicate with each other. They are being kept separate, even though they're running on same physical server, but they deploy some techniques, some firewalls. They use some strategy to ensure that every instance is isolated. By default, there's no communication between the two instances on the same physical server. Of course, you can open some ports. You can do it. We'll discuss that afterwards. So based upon that, they give you, or they offer you, two types of tenancy options. One is shared, and the other one is dedicated. So what's the difference? On a shared tenancy, so let me tell you the differences. If you have the shared tenancy, this is the same hypervisor. This is the Zen hypervisor. This is the Zen hypervisor. Upon the same So the thing is that if you go with a shared tenancy, upon this physical server, these instances might belong to different individuals or organizations. For example, this can belong to, if I just, for example, go with this one, this instance, let me just label it. So I can say this instance can belong to AIG. These two instances will belong to, let's suppose, HCL. This belongs to Accenture. Upon the same physical server, different virtual machines are running, and these virtual machines may belong to different individuals and organizations. This tenancy is called shared tenancy, right? Now, this tenancy is free of cost. Not the instance, only the tenancy I'm talking about. This tenancy is free of cost. And they guarantee you the instance isolation. However, if you have some extra money and due to some security, compliance, or software requirements, you may go for a different tenancy that's called the dedicated tenancy. For example, you are a financial institution or banking organization, and your legal requirements, your compliance requirements may not allow you to deploy the instance of virtual machines on the same physical platform. Or there's another example, the Oracle Enterprise Edition Database. They can't be run on a shared tenancy. You have to run. So Oracle Enterprise Edition Database should be up and running. On a dedicated tenancy. So what happens in a dedicated tenancy? What happens is, it's a simple concept. This is a physical server. There's the same HP, IBM, or Dell physical server. And this is the same Zen hypervisor, the client software. Now, all these virtual machines will belong to the same customer. All these virtual machines will belong to same customer. So you'll book or you allocate yourself the complete physical server, and will say that, okay, only my virtual machines will be deployed upon this physical server. Right? This is called dedicated tenancy. We have dedicated tenancy is not free. You have to pay for dedicated tenancy. I'm not talking about the instance or the virtual machine. I'm talking about the tenancy only. You have to pay for it. Fine. So in few cases, due to software, legal, compliance requirements, you might go with dedicated tenancy where you book the entire physical server and only your instances can be launched upon them. So these are two types of tenancies that you have to understand from the operations point of view, because it's very important that once you deploy the instances or the virtual machines, you have to choose any one of these two options. Shared is default, and dedicated is not default. You have to explicitly choose it. Fine. So that's the concept. So this is the 6th concept that we have discussed that. Okay. This is the 6th concept. So as of now, we discussed these 6 concepts. Let's go to the next concept. That's the CloudWatch monitoring. The 6th concept that we'll discuss right now is monitoring. See, the thing is that in any environment, whether it's a cloud environment or it's a in-house environment, it's very, very important. It is extremely important that you should be able to monitor the performance of the instances or the resources. Now, in AWS, CloudWatch, so CloudWatch is the default monitoring tool. There's a separate lecture on CloudWatch we'll discuss in detail afterwards. Okay. Now, how CloudWatch works for you? Basically, in CloudWatch, we defined metrics. These are parameters using which we analyze a resource performance. For example, I want to gauge the height of a person. I use feet. I want to gauge the length and breadth of my table. I use inches or centimeters or millimeters. Okay, these are the parameters against which you analyze the resource's performance. Now, how it works for us? Let's imagine this is my EC2 instance. What's that? This is my EC2 instance. And on the left hand side, this is the CloudWatch dashboard. What's that? This is the CloudWatch dashboard. Now, these are two different resources. These are two different resources. So this is my CloudWatch dashboard. Now, I want this CloudWatch to analyze its performance. So what I can do is that this is me. This is the system administrator. This is the system admin. He wants to log into the CloudWatch and see exactly that how instance is performing. Now, first of all, the first step is that this instance will report or push its metrics. For example, CPU utilization. The instance will deposit or push the metrics to the CloudWatch. Okay, for the very first time. Then after that, this instance will also give the statistics for that metric. For example, it will push the metrics along with the statistics. Metrics plus the statistics. For example, it will say that CPU utilization is presently 70%. So the instance will report metrics and statistics to the CloudWatch. And you can log into the CloudWatch and see exactly what's going on. Now, so the instance, what it will do, it will report the metrics and statistics. There's a frequency of reporting. By default, the frequency is 5 minutes. Default frequency. Okay, so write it down. So let's take this once again. Let me just write it down. This is the instance. This is the same EC2 instance, and this is the CloudWatch dashboard. Now, by default, every 5 minutes, this instance will report metrics along with statistics. For example, what's a metric? CPU utilization. And what's the statistic or value? 70%. Fine. Now, the frequency is 5 minutes. And you can log into the CloudWatch and you can see it. So, the default / standard monitoring is of 5 minutes frequency. Now, this is a question that comes in the exam. Every 5 minutes, the instance will report the metrics along with the value and the statistics. And you can see exactly the value of it. So after every 5 minutes, the instance will report metrics and the statistics to the CloudWatch. Okay. This is called the default or standard monitoring. Now this is free of cost. There is no charge for it. This is free of cost and there is absolutely no charge for this one. Okay. Then if you want to go further, you can go with the detailed monitoring. This is called detailed monitoring, the frequency of which is 1 minute. After every 1 minute, the instance will push the metrics along with the statistics or the value. This means that you're increasing the number of communication channels, or I would say API calls, between the instance and CloudWatch. Every 1 minute, then instance has to push the metrics along with the statistics. You're utilizing more bandwidth between these two different services. That's why you have to, this is paid. This is not free. You have to pay for it. For standard, you don't have to pay. The frequency is 5 minutes. It's free of cost. But in case of detailed monitoring, the frequency is 1 minute. You're increasing the number of communication streams going between the instance and the CloudWatch, and you have to pay for it. This is a question that comes in the exam for sure. I would say based upon this concept I discussed with you right now, a question always comes in the exam. Fine. We'll discuss the CloudWatch in detail in one of the lectures, but from the instance perspective, this is more than sufficient as of now. This is more than sufficient at this stage. This is more than sufficient. You don't have to go beyond it. Fine. So this is the seventh concept that we have discussed at the monitoring. Fine. Let's discuss the 8th concept. The 8th concept that we discussed right now is the EBS, which stands for Elastic Block Store. This we have to define when we launch the instance, hence I have to just brief you about it. Elastic Block Store, it defines the block level storage for instances. It defines the block level storage for the instances. It defines the block level storage for the instances. The concept of the EBS is, or the Elastic Block Store is, that, okay, first thing first, it has 2 categories. If I say EBS, it has 2 categories: volumes and snapshots. I'll discuss volumes right now, snapshots we'll discuss afterwards, but I'll just brief you about it. What happens is that how it works for us. Let's understand that. Let's imagine this is my instance. See, every server, whether it's a virtual server, it needs some storage to boot up, to install the application services upon it, to store the content. That storage is defined by EBS volume. What you do is that you attach it and you mount it upon the instance. Now, if you as a system administrator, if you log into the instance, you can see it as a C drive or a D drive, as a local drive of that instance. So you may be mistaken by this fact that the volume and the instance are on the same physical server. Like you're using a laptop or a desktop, the hard drive is embedded on the same machine. But in this case, AWS takes a different approach. What they do is that they will have the instance running on a different physical server. For example, it can be running on an HP, IBM, or Dell physical server. It can be running upon the HP, IBM, or a Dell physical server. But regarding the EBS volume, it can be running a part of a NAS, SAN, or a disk attached storage. This means that even though they seem to be running on same physical machine, but they're running on different machines. They're running on different hardware components. Okay. So how this will benefit you? What's the benefit? This benefits in such a way. First of all, upon the volume, your entire data is being saved. Your entire data plus your images. If it's a root volume, fine. Your entire data and optionally all the images are being saved on the volume, not upon the instance, upon the volume of that instance. Now, since that these two different components are running on two different hardware components, you make them independent from each other in such a way that if this instance crashes, or the underlying physical server crashes, or this instance terminates. Terminates means that if it's deleted permanently. Okay. Then on the left hand side, this volume on the left hand side is unaffected. You can take this volume and attach it to any other instance in same easy. This is very important. And recover the entire data. And you recover the entire data. Basically, what you're trying to do, you make the volume independent from the life cycle of the instance or the physical server. And you can retain the entire data. So you can detach it from here, and what you can do is that you can attach it to any other instance in the same easy. To another instance, I would say that. To another instance in the same easy. So this is very important. I'll elaborate this concept with you in detail afterwards. Fine. And okay, so we understood this concept. What about the snapshot? So this is the concept that we discuss about that. And what about snapshot? Snapshot is nothing. It's a backup of the volume. If this is the EBS volume, you can take a snapshot out of it. What you can do is that you can take a snapshot out of it. This is the backup. You are backing up the entire data on the volume. The snapshot data is saved into one of the S3 bucket. It is totally managed by AWS. This is the backend process. You can't see it. So if you back up the entire data of the volume in the form of snapshot, that entire data is being saved into one of the S3 buckets managed by AWS. You can't see that bucket. It's a pure backend process. Once we discuss the EPS, I'll discuss this concept with you in detail. So the next concept that we have to discuss right now is the concept of security groups. Let's understand that concept now. See, it's very important that whenever we launch our instances, we need to ensure the security of them. Fine. So it's very crucial that you understand exactly that how the security group will play an important role. Guys, I'll take all the questions in the middle of the session. Whatever part is not clear, I'll take all the questions. Fine. So what's the purpose of security group? Why we need that? See, right now, let's imagine this is the Amazon Web Services Cloud. This is the AWS Cloud. And this is the instance. This is the EC2 instance. Now, it's very important that you have to understand one simple fact, that how exactly you can ensure, because the thing is that let's imagine that this instance is running, right? It will receive traffic from outside, and also it will generate traffic to outside. So the traffic will come from outside and the traffic will be sent outside from the instance. So basically we want to restrict the incoming and the outgoing traffic. We want to restrict the incoming and the outgoing traffic. How we do that? We make use of the concept called security groups. So what is a security group? A security group is nothing but it's a virtual firewall. It's a virtual firewall. Okay. And basically what it does is that through this it restricts the incoming and outgoing traffic for the EC2 instances. The main purpose of the security group is that it restricts the incoming and the outgoing traffic for the instances. Fine. So it's very important that you perform the restrictions with utmost care, because this is where a lot many administrators, they make blunder. They open some ports that need not to be opened. Okay, I'll discuss that in detail. So the thing is that you filter the traffic. So how you filter the traffic? So what are the three main filters that you have to apply to restrict the incoming and the outgoing traffic? The three filters that we apply are the following. The first filter is the protocol. Okay, protocol is the first filter. Second filter is port. Now basically the port depends upon the protocol itself. I just give you one example. For example, HTTP uses the standard port 80. HTTPS uses the standard port 443. MySQL uses the standard port 3306. These are standard ports that we use. These are industry standard. You can't change them. Of course, you can also define your customized ports. You can do that. So the first filter is protocol. The second filter is port. So most of the times the port and protocol are static in nature. You can't change them. The third one that you can change, and that's the most important thing that you have to change or you want to apply, is the source/destination IP address. Source/destination IP address. This is what you have to customize very importantly, or very cautiously, because port and protocols, you don't have to customize it anyhow. You just include them. But the main thing is that you have to change the source and destination IP address. I'll just tell you the differences, how they work for you. Fine. So these are 3 filters that you want to implement. Now, the thing is that you explicitly define the incoming rules, which means that what type of traffic you want to hit the instance from outside. And you define the outgoing rules, which means that what type of traffic can be sent from the instance outside from the instance. It can generate the traffic to the outside environment. So you restrict the incoming and the outgoing traffic, and you do that by separately define the inbound and the outbound rules. Fine. I'll show you how you configure it. The configuration I'll show you afterwards. But let's understand the concept first. First thing first, what are a few things that you have to understand, or what's the most important thing? The most important thing is, okay, one thing that we have to understand. Let's take one example. Let's imagine this is the AWS cloud, and this is the instance. What is that? This is the instance. But this is the Linux instance. See, there are 2 types of operating systems you can install upon the instance. Either it's Linux or it's Windows. Linux or Windows. You can have any one of these 2 instances, any one of these 2 different operating systems installed upon the instances. It can be the Linux or it can be the Windows. Fine. Now, the thing is that, let's suppose if it's a Linux instance, and this is you. You are the system administrator. You need to remote into the instance from your data center or office or from home to ensure that you can log into the instance. You want to basically, what you want to do is that you want to, what's the main purpose? The main purpose is that you want to get the root access to it. Okay. So you want to, the main purpose is that you want to get root access to Linux instance. That's your main intent. That's your main purpose. That's the main intent, and that's the main purpose. What you do is that you SSH to the instance. You initiate SSH. Now, SSH stands for Secure Shell. It uses port, right? 22. SSH stands for Secure Shell. It uses a static port 22. Basically, you want to initiate the SSH or Secure Shell port, access over port 22. So use SSH on port 22 to get the root access to the Linux instance remotely. Okay. And this is what's a protocol that you'll be using. Now, the thing is that the source IP should be the known IP. Okay. The source IP should be known IP, because this administrator is using a laptop or a computer, a desktop. That IP address of that machine should be known, should be recognized. Okay. So the source IP should be known IP. You should not allow SSH, which uses port 22, from anywhere. What do you mean by anywhere? Anywhere means that anyone can get the root access. See, root access means that you're giving the key to the person, so he can open the server, he can perform the administration, he can install the operating system, run some commands, right? So SSH should not be allowed from anywhere. It is strict no, right? So SSH from anywhere shouldn't be allowed. This is very important. Fine. So the SSH traffic for the Linux instance should come from a known IP address. Anywhere IP address means it is 0.0.0.0/0. Then there are 2 colons 0. This means anywhere. So SSH should not be allowed from anywhere. This is strict no, because this means that you're welcoming, because this means that any person on internet, any person can access, or I would say can get the root access to, let me just make it more clear, can get root access to Linux instance. This is very important. So you don't want to, so like for example, you have a lock on the door, on the main door of your house, right? Who has the key? The people in your family has the keys. Will you throw the key outside and anyone and allow any intruder to come into your house? No. If you open this thing, this means that you're opening your main door in the middle of the night and anyone can get into your house. So this means that you're opening your main door. You should not allow the root access from this IP address. The SSH access for Linux instance should not be allowed from this IP address. It should be allowed from known IP. It should be allowed from known IP. Fine. I'll show you the configuration. It will be much more clear exactly that what exactly I'm talking about. It will make more sense. Fine. Let's take one more example. Let's take a third example that this is the AWS cloud, and this is a EC2 Windows instance. This is the EC2 Windows instance. This is the EC2 Windows instance. Now, for example, this is you. You are the system administrator. You're the system administrator. And you want to get the root access to it. You want to, sorry, hang on 1 second. You want to get the root access to it. So being a system administrator, if you want to get the root access to the instance, so you want to get root access to this Windows instance. You want to get at the core of it, root access, not the web access, root access. Then the protocol that you use is RDP, which uses the port 3389. It's a static port. You can't change it. There's no way to change it. The port it uses is, the port that it uses is 3389. You can't change this port number. Fine, 3389. So the same concept applies over here. The source IP should be known IP. You shouldn't allow it from anywhere, which is 0.0.0.0 2:0/0 2:0. So basically what it wants to convey is that you should not allow it from anywhere. The root access. Let me just write down once again. It is /0, then 2:0. You should not allow it from anywhere. This is very important because the root access should be given to only system administrator from the source IP. Fine. So whether it's RDP for Windows, whether it's remote desktop protocol for Windows, or whether it is SSH for Linux, these are the protocols that should be allowed that should be entertained from the source IP address. This thing you have to understand. If you understand this thing, the things are very much clear. Of course, if I show you the configuration, it will make a lot much sense to you. Because right now, of course, things may be going over your head. That's fine. because the thing is that we are doing the thing for we are understanding these concepts for the very first time. So that's fine if you have some problem understanding it, because once you start implementing it, then you get the essence of it. Fine. Now let's take one simple example, and I show exactly that how it works for us. So let's take one example and let's understand how this works for us. If you understand this example, then this means that you have understood the purpose of using the security group. Let's take one example. Let's imagine this is the AWS cloud. Fine. On the right hand side, this is your data center. These are the windows. So this shows a building. This is your branch office. This is your branch office, your corporate office / your data center. I'll write down as DC in the short form. Now on the left hand side, these are your end users. I would say these are the internet users. Okay. And this is the EC2 Linux instance. Now upon this Linux instance, you have installed the Drupal web application, a website, a Drupal web app. Okay, a web application, a website. You have launched a website upon it. Okay. Now, how exactly you segregate the incoming traffic that hits this instance? Just understand this concept. See, the people who are sitting in your office, basically what happens is that every office, every network has a range of IP addresses. For example, your office can have the IP address range of, let's take one example, 56.10.0.0/16. I'm just giving one example, right? This is the range of your data center network. Fine. You want the people from your office to, because in your branch office you have the system administrators, or I would say developers, they need to SSH to the instance so that they can perform day-to-day operations. They can install the scripts, softwares, applications. They can shut down the instance, install some scripts upon it, right? So what you will do is that you will allow the SSH from this IP address range. You will say that SSH should come from 56.10.0.0/16. Fine. You got the point? So you're saying that SSH is allowed from this IP address range. Fine. So you're giving the root access to them. Now these internet users on the left hand side, they want to browse the website, this Drupal web app. They want to access the Drupal web application running upon the instance. So basically you want to give them the web access, that is HTTP or HTTPS, because you're just giving them the access to the website running upon the instance. So you can say that HTTP/HTTPS can come from anywhere. That is 0.0.0.0/0, then 2:0. So you understood the point. I'm saying that the root access is given to the known people. I'm giving the key of my house to my relative, to my family member. But any outsider can see the outside view of my house. So I'm saying is that the root access is being given to the known people who can log into the root of the server, and they can perform day-to-day operations. But the people who are from outside, I just allow them to access the website running upon the instance. See, right now, you go to facebook.com. You can just access the website running upon the instance. Fine. But you can't access the underlying server. Underlying server is being handled by Facebook administrators who work in their office. They perform day-to-day operations. So root access is given to your employees, the people in your IT and software teams, and the internet access or the HTTPS access is given to the outsiders who can access the website running upon the instances. Fine. This is exactly how the concept applies in terms of security group. Now, I'm pretty much sure that to most of the people, it will not make any sense as of now. But the thing is that once I start showing you the configuration, I repeat the same concept, show you that how you apply it, then you'll be able to understand the concept. Fine. As of now, you just understand the theory. Just try to get the essence of it. Fine. Because right now, it's like an exercise. Before you exercise, you go to the gym, you do the warm-up, right? It's like a warm-up for you. Once you do the warm-up, and once we start doing the main course of exercises and understanding the entire implementation of the stuff, then you'll be able to understand exactly that how these things fit into the deployment of the instance. So this is the example that the best example I can give you in terms of understanding the concept of security group. Fine. So that's the thing. So this is the 8th concept. Fine. This is the 8th concept. Let me discuss with you, 9th concept. Let me discuss with you the 10th concept, and then we'll just switch over to the launching process of the instance. The 10th concept is the key pair. Now, what the key pair is nothing but it's a AWS method of authentication. This is the authentication standard they use. Method of authentication. See, authentication means that how you can log into the instance, how you can log in, or what's the password or the username you use. AWS prefers this method. You can also make use of your own methods, but you can also, by default, this is the method of authentication. What happens in this is that we have a key pair, which consists of 2 keys. One key is the public key. This is embedded. I would say this is a part of AMI. This is embedded, or this is the part of AMI of the instance. And then we have the private key. The private key is the one that you store locally. Okay. So the thing is that you make use of these 2 keys to access your instance. It's a method of authentication. Basically, what you do is that, let's take one example. Let's take one example. This is an instance, right? This is a Linux instance. You want to SSH into the instance, and you choose your own IP address to SSH to the instance. Now, once you initiate, then you have to, the first layer of security is the security group. Then you have to, once you get access to the instance using SSH and you use your IP address, which is a known IP, then the next thing that you have, the next barrier that you have to go through is the authentication. What you do is that, or what exactly happens is that this instance will have the public AMI. Let me just go 1 second over here. So this is your known IP. This is the known IP address. Now this instance already has a public AMI embedded in public key embedded into its AMI of the instance. It is embedded into the AMI of the instance. Use a private key, or I would say, I'm sorry, that means right over here. You then present the private key that matches the public key, and then you're able to authenticate. So you, first of all, the first step is that you SSH, and the second thing is that you provide the private key. You SSH to the instance, and then you upload the private key which matches the public key. So what's the first step? What's the first barrier? You have to SSH using known IP. And the second barrier that you have to go through is that you have to match your private key to the public key. And if the match is appropriate, then you're able to authenticate and get access to the instance. See, it's like if you have bank lockers, if you maintain lockers in the bank, how you open those lockers? You go to the bank, you fill a register or kind of an entry. You just enter to the premises. You just mention your name and you just put in all the details. You go to the locker room. You're being escorted by a bank official. You have your own key. You use the key to your locker to open it up. Your bank official will also use his or her own key to unlock the locker. If both the key match, and this means that both the keys are appropriate, then you're able to open the locker in your bank. So the same concept applies over here. There are two keys. One key is embedded into the AMI, and one key is the one that you store locally. Once you SSH the instance, you have to present your private key that matches the public key. And if the match is appropriate, then you're able to authenticate and get access to the instance. Fine. So these are two different security layers that you have to go through. These are two different security layers. That being said, this completes the concept of EC2. I shall now go ahead and start with the launching process. And once we are done launching this thing, then I take all your questions. Fine. So you have to excuse me because it's very, very important that I take your questions, and then I can start with the next concept. So you just allow me a few seconds over here. I just log into my AWS Management Console, and then I just start with the launching process. Guys, just pay utmost attention to the concepts. Fine. I repeat those the same concepts. Don't worry about that. All the questions will be answered, but the thing is that you have to give me some time. So your patience is needed right now. Give me some time. All your questions will be answered. Because now I'm starting with the deployment. So I go to the compute section. So first thing first, before you can launch the instance, you have to choose the appropriate region. I choose the appropriate region as my EC2 under the compute section so that I can access my instance dashboard. Now, once I go over there, I can see the service health status, the region, and its AZs are available. I can start using them on the fly. Now, the thing is that this entire page is called the instance dashboard, or it's called the EC2 dashboard. EC2 dashboard, from where you can manage your instances, images, EBS, network and security, load balancing, auto scaling, blah, blah, blah. There's so many things you can access, right? Because EC2 is the amalgamation of multiple services. Now, I click on launch instance right now. And the very first thing that it presents me is the AMI. We discussed that. What's the AMI? It's the pre-configured template. I can just show you the definition on the top. An AMI is necessarily a template that contains the software configuration, which includes the operating system, application server, and applications that are needed to launch the instance from scratch. it's very important that you have the AMI. So AMI is of utmost importance. AMI is very important because without AMI, you not have the information to boot the instance from scratch. Okay. So if I just go back to the same notes, what we discussed about the AMI, let me just go back. I'm sorry, I think I accidentally opened my iPad camera. So we discussed that. Just give me 1 second over here. Yeah. Let me just rotate my iPad screen. So what we discussed about the AMI? We discussed about the AMI is that it's a pre-configured template. It's a pre-configured template. Right? This is the concept we discussed. An AMI is a pre-configured template using which we define the operating system. It can be the Linux or Windows, applications, services, softwares, and scripts. Right? It's a single package that we install upon the instance. I give you this example that, for example, we have Ubuntu 16.04 plus MySQL database, WordPress site, and blog. Okay. So an AMI represents the operating system, applications, services, softwares, and scripts that are needed to boot the instance from scratch. Now, if we just go back to the instance dashboard, these are different flavors of AMI. For example, on the top, these are different Linux distributions, Linux AMIs. For example, Amazon Linux, Red Hat, then Ubuntu. And then we have the Windows-based AMIs. These are different Windows-based AMIs, Microsoft Windows Server 2019 base, then base with containers. So you can see that there are different flavors of Linux and Windows-based AMIs. The one that are labeled as free tier eligible, this means that you can use them with a free tier account without incurring any charges. This thing is of utmost importance because in a free tier account, if you want to do some hands-on without incurring any charges, please make sure that you make use of only those AMIs which are free tier eligible. Okay, so these are the AMIs, and every AMI will consist of the unique AMI ID. It's the identifier of that AMI. Now these are the public AMIs. These are the pre-configured and pre-baked AMIs. Anyone can use them. If you open your dashboard, you will see the same AMIs. These are public AMIs. Anyone can use them. But the thing is that in an operation environment, in a production environment, we make use of my AMIs. Previously, we were on quick start. Let's go to my AMIs. My AMIs is a space which from where we can maintain a repository of customized AMIs. See, I'll show you later on that how you manufacture customized AMI. If you have your own customized AMI, then you can install upon the operating system plus the customized application and services of your own choice. Okay. And from that customized AMI, you can launch any number of instances. So later on, I'll show you exactly that how you can manufacture and maintain the customized AMIs. Then we have the marketplace. Marketplace is a space from where you can purchase the AMIs from them. Basically, it is a software as a service concept. The different software vendors like SAP, Xent, Microsoft, Juniper, F5, you can purchase the AMIs from them. So for example, let's go to Juniper. I want to launch Juniper VSRX next generation firewall in AWS Cloud. I click on this right now. So basically, I can just click on this right now. I can see the product description, the details of it. If I use this AMI, if I just launch my instance using this AMI, I get a free trial for 30 days. Okay. Now, these instance types, I'll discuss with you afterwards. Basically, it depicts the the hardware configuration of the instances, you will see that there's a total charge. For example, 76 cents per hour. It includes the software fee and the instance fee. Software fee, so the thing is that you don't have to contact Juniper. You pay this total amount to AWS and they will distribute 55 cents, or they will give 55 cents to Juniper, right? So you pay the total amount. The software fee will go to Juniper and the EC2 fee will go to AWS. So the thing is that you can purchase the AMIs from here, right? You can explore it. It's a very big market space. You can explore, you can get thousands of products in the form of AMIs. Then we have the community AMIs. Community AMIs means that it's a free space. Most of the AMIs over here are free. Any one of us can share the AMIs and put it on this page. It's like we share the post on the Facebook or pics on the Instagram. Similarly, we can share the images on this free space. Fine. So this is a community effort. As of now, we have more than 40,000 community AMIs. It's very rare that you will use that in a production environment. For the lab purpose, of course, you can use any one of them. It's pure your discretion. Now, let's go to quick start. And let's do one thing. Let's choose Amazon Linux AMI. Fine. Click select. Then the next thing that we have to discuss is instance type. Now I discussed instance type with you. What's instance type? It's the virtual representation of the underlying physical resources. See, basically the thing is that you choose instance type depending upon what's the software, not the software, I would say that, what's the hardware configuration of the instance, right? For example, in a free tier account, we get T2.micro instance type, which gives you one virtual CPU, 2.5 gigahertz Intel Xeon family processor, and 1 gig of RAM. It is decent enough for you to do some practical exercises or run some small applications. As we move forward, you will see that there are different categories of instances. For example, compute optimized, which give you more compute capacity. Then we have GPU optimized, which gives you more graphical processor units. It's used for 3D based or video based applications. Memory optimized, which gives you a lot of RAM. Okay. So storage optimized, which gives you a lot of storage. The higher you go, the more resources that instance offers, the more you have to pay. Fine. So basically it's like you're going to Best Buy store and you want to buy a laptop or a desktop. The more RAM, the more storage that laptop or computer has, the more you have to pay. Simple. If any device gives you more features and more hardware capacity in terms of RAM, CPU, storage, processor, you have to pay more. The same concept applies over here. And the question really is how are you gonna comprehend that which one is the best for you? See, basically you have to match any application that you deploy upon the instance will have certain requirements in terms of CPU, RAM it needs. You can match those requirements with instance specifications. Okay. Still, if you have some confusion, you can choose any of the instance type which you think is closest to that requirement, and later on this can be changed. Yes, this can be changed afterwards. For example, I can launch my instance using T2.micro instance type, but after few hours, a few days, or few weeks, few months, or 1 year, I can change it to a different instance type, or I can downsize it to another instance type. It's scalable. Fine. It is just that there's a downtime. You have to shut down the instance for a few seconds. And then you can change the instance type. If you think that the compute capacity is not sufficient or more than sufficient, you can upgrade or downgrade the instance type. Okay, I'll show you that afterwards. As of now, I'll go with T2.micro as my instance type. It is free tier. eligible. I click on next, configure instance details. Now, the next thing that comes is the instance details. Now we have discussed most of these options in our conversation. The very first thing is that we define the number of instances. In one single shot, we can launch multiple instances in one go. For example, we can choose 10. We can mention 10 as a number. So in this case, it will deploy 10 instances in one single shot. Fine. So it will deploy 10 instances in one single shot. But as of now, I just make it as 1. There's an option which says launch into auto scan group. This is used for automation. We'll discuss that afterwards. Purchasing option, we'll discuss that afterwards. Basically, this is the on-demand instance, which means that this will be built based upon the number of hours consumed by this instance. This is the on-demand instance. So we'll discuss the purchasing option afterwards. This is very important. VPC or the virtual private cloud. See, I discussed with you the VPC, right? Let me just go back to the iPad screen and the notes that we have this formulated. So the thing is that we discussed the concept of VPC. What's a VPC? It stands for virtual private cloud. It's a virtual data center which gives you a lot of security, flexibility, and transparency. Basically, VPC is launched in a region. It consists of the subnets, and each subnet is linked to a specific availability zone, and each subnet will consist of the instance or instances. Fine, you got the point. Now the thing is, by default there will be a default VPC pre-configured. There will be a default VPC. Now you choose any one of these subnets that will be linked to a specific AZ. For example, this subnet A44E04EC is linked to AP South 1A. The second subnet 7E1BA332 is linked to AP South 1B availability zone. So if I choose any one of these two different subnets, for example, I choose this subnet. If I choose this subnet, this means that I'll be launching my instance in AP South 1A AZ. But if I choose the second subnet, then my instance will be launched in AP South 1B AZ. Fine. However, Amazon recommends that you choose no preference. If you choose no preference, what happens? If you choose no preference, then I leave it to AWS so that my instance can be launched in any one of these two different subnets. Any one of these two. So I choose no preference. Now my instance will get the private IP depending upon the range of the subnet it will be launched into. Okay, let's choose this subnet. Whatever range this subnet has, if it has more than 4,000 private IPs, whatever range of this subnet is, my instance will get the IP address from that range, the private IP. And also, it will be assigned a public IP. The private IP is used to give the internal recognition so that the instance can communicate with any other instance internally on the same network. But if I want this instance to be exposed to the internet, then in that case, I enable the public IP so that apart from having the private IP, this instance also has a public IP. If I want, I can disable it because this is optional, but I can re-enable it. Placement group. Okay, I will discuss with you the placement group. It's a very basic concept. Basically, the placement group is nothing but it's a logical collection of instances. Let me just discuss with you that concept because I skipped it. So what's the concept of this placement group? You understand this concept, right? Basically, the placement groups are of different types, but the main thing that we discuss or we use is the cluster placement group. What is that? That's the cluster placement group. Okay, so what's the concept? in the cluster placement group, what we do is that we intentionally cluster the instances in a single AZ. We intentionally cluster the instances in a single AZ. Fine. So why? Because we want the applications to benefit from low latency and high throughput network. This makes the instances in the same AZ, the process of communication much faster. Okay, we intentionally cluster the instances in a single AZ. So how this works for us? Let's imagine that let's imagine we have multiple instances. Let's take this example right now so that you understand this concept. Right? This is instance A, B, C, D, E, F, G, H, I. Right? These are multiple instances. Now I want them to communicate, the applications running upon them should communicate with other instances in a much faster way. It's a kind of cluster. There are few cases where you want to cluster these instances. You are clustering them. This is clustering. Okay. For example, if A wants to communicate with E, it can do faster because it is in a single AZ. Applications running upon them can benefit from low latency and high network throughput networks. That's a concept of placement groups. Fine. Now it is just the combination of instances in a single AZ. That's it. It's a logic grouping. It's a logic grouping. Now this is very important. Not all instance types support placement groups. For example, T2.micro doesn't support the placement group. Fine, this is very important. So the lower instance types, they don't support the placement group. Okay. As if now we're going to skip this configuration and go to capacity reservation. So I can make this part as a part of the existing placement group, but as I've discussed, T2.micro doesn't support this feature. Then we have the capacity reservation. Now this is a new feature they've come up with. Basically, you're saying that if I can make it open, or I can, yeah. So what I'm saying is that I can reserve this instance for few hours or few days. Basically, it doesn't make any sense as if now you can reserve this instance or its capacity. We just set it to none. IAM role, we discuss the IAM role. In the IAM, basically I can choose access to my S3 buckets, the role that we have pre-configured, so that this instance can access the instances. This instance can access the buckets in the future. If you remember, we discussed the concept of IAM role. The concept of role is that two services, the instance and the buckets, can communicate. We discussed that, right? So I can apply this role to my instance. Shutdown behavior. There are two shutdown behaviors. By default, it's stop, which means if I shut down the instance, it stops. Then I can start it once again. Stop it, start it. Stop it, start it. But if I choose terminate, If I choose terminate, this means that once I shut down the instance, it is permanently killed. It's permanently deleted. I can't get it back. Okay, so I choose stop. You can enable the termination protection. You can immune this instance from accidental termination. If I check mark this option, then the terminate option is grayed out. It's disabled because my instance dashboard can be accessed by 100 IAM users. And there can be a chance that someone might accidentally delete this instance. Might be this instance I'm launching is a master server in my Hadoop cluster. So I don't want to take any chance. So I can protect against accidental termination. Then monitoring. By default, we go with the CloudWatch standard monitoring. If I check mark this option, it becomes detailed monitoring. Remember, we discussed two types of monitoring. Let me just go back to this thing. So we discussed two types of monitoring. One is the detailed and the other one is the standard. So the default or the standard monitoring means that the instance will report the metrics along with the statistics after every 5 minutes. After every 5 minutes, you will see the new updates showing up on the CloudWatch with respect to the instance performance. That's the default or standard monitoring, the frequency of which is 5 minutes. But if you just go with the detailed monitoring, we increase the frequency to 1 minute because now every 1 minute, the instance will report the metrics along with the statistics to the CloudWatch. And this is a paid feature. So let's go back right now and I'm gonna uncheck it. If I keep it unchecked, it remains standard, the frequency of which is 5 minutes. But if I check it mark, it becomes detailed, the frequency of which is a minute. Tenancy, we discussed that. There are two tenancies, shared and dedicated. Shared means that I'm running the instance on a shared hardware. I don't have to pay for this tenancy. If I go with dedicated, then I have to pay for dedicated physical server. In that case, I'm the only one to pay for it. My instances will be launched upon this instances. Only my instances will be launched upon the instance, but I have to pay the additional charges for the dedicated. So I go with the shared. T2, T3 are limited. Now, basically, this is applicable to T2 or T3 instance type. If you want to burst the CPU performance of it, then in those cases, it can burst the CPU performance. But in that case, you have to pay some extra charges. So I'm gonna make it unchecked. Network interface. Now there's a default virtual interface that will be assigned to the instance. So we're gonna keep it default. Under advanced details, we have the user data where we can copy and paste the scripts like bash scripts, Perl scripts, Python scripts. So that once this instance gets launched, then automatically it can launch the services and applications upon it. It's called a bootstrapping. We're going to discuss that in the future in detail. Okay. Now I click on Extract Storage. Now we discuss about the EPS volume. By default, it allocates 8 gig of EPS volume to the instance. And the maximum size of the volume that we can assign to the instance is 16 terabyte. Okay. So this is the EPS volume, the virtual disk that we are assigning to the instance. We'll discuss the volume types, IOPS and throughput afterwards because they are the part of EPS, not discussed right now. But the main thing that I want to draw your attention towards is the root volume. Root volume is a main volume, which means that it consists of the information which is necessary to boot the instance from scratch. So this is my root volume. Now, on the right hand side, we have this option delete on termination. What exactly this is? See, if I uncheck this option, this means that if I terminate the instance, terminate means that if I permanently delete the instance from my account, then this volume of 8 gig will not be deleted. Will not be deleted. Right? Will not be, because the volume is running on a separate physical server. If the instance crashes or if the instance terminates, then my volume and the data should not be affected. So I will uncheck this option. Fine. I click on Next Add Tags. Now this is nothing but a tag value you assign to the instance. It's just for the documentation and for the billing purpose. So I can name it as my, let's assign a name to it. This is Amazon Linux instance. Click on Next Configure Security Group. Now this is what we discussed in security group. We can restrict the incoming and the outgoing traffic with respect to the instance or instances. Okay, we can restrict the incoming and the outgoing traffic with respect to the instance or the instances. First thing first, we have to assign a name to it. We have to assign a name to it. So I just assign a name. This is my Amazon Linux AMI, or I just type in security group. Fine. Let me just. Fine. And that's it. I can assign a description. The description just gives you the description or the purpose of this group. Let's type in this security group will be assigned to the Amazon Linux instance. Fine. So I just assign a description of this security group. Now, SSH, which means that anyone can get the root access to the instance. By default, it shows 0.0.0.0.0.0/0, which means any IP. You can see a warning message. Rules with the source 0.0.0.0.0.0/0 allow all the IP addresses to access your instance. We recommend setting security group rules to allow access from known IP addresses only. So in that case, so these are list of protocols. SSH, the type is TCP, the port is 22. And the source is custom. So it is any IP. So what I do is that I choose my IP. Remember, SSH for Linux, RDP for Windows should be allowed from the known IP addresses. Should be allowed from known IP addresses. So if I choose my IP, it automatically populates the IP address of my computer right now. I'm using an iMac to conduct this session, upon which I'm running this management console. This computer is getting an IP address from my service provider. I'm saying that if I choose my IP, in that case, I'm the one who can get a root access to this instance. Or I can choose custom source. Okay, let me do one thing. I can choose custom source and I can define the IP address of the IP address range of my data center. So this is, I can include a description, SSH allowed from my data center, so that people can SSH to my instance. Then I can, if I deploy any website upon the instance, I can allow HTTP from anywhere. and HTTPS from anywhere, right? If you go to the same, if I show you the same thing that I discussed with you, the same thing. Let me just go back to the same concept. So SSH and RDP should be allowed from RDP for Windows should be allowed from known IP. And the same diagram shows up. The same concept. The SSH is allowed from the known IP, your data center IP. Either it is a computer IP or the complete environment IP address. So the SSH or RDP should be allowed from known IP address. And the HTTP or HTTPS access can be allowed from anywhere. So I can say HTTP access from anywhere. Fine. And I can just type in HTTPS access from anywhere. Fine. Click on, so you can see that SSH is allowed from a custom source. I can choose my IP or define a complete IP address range. So SSH from my iMac. And HTTP and HTTPS can be allowed from anywhere. I click on review and launch. I can review the options. So I can review all the parameters and just click on edit and make the changes. But as of now, I don't have to make any change. Then I click on launch. Now this is the last step where you define the key pair. Yeah, we discussed the public key and private key. Public key is the one that's being stored by AWS. It's embedded into the AMI of the instance. And then we have the private key that you store on your computer. So you click on create a new key pair and you define a name of the key. Let's type in Amazon Linux. Let me just type, make it short, AMZN Linux -HE. Fine. I click on download key pair. It downloads the key pair. And this is the private key. Let me just drag and drop that to this screen. Can you see that? This is a complete algorithm. Once I click on download key pair, it downloads the key, the private key on my desktop. Okay. I'll use that afterwards. I click on launch instances and this launches my instance from scratch. This launches my instance from scratch. I click on this thing, instance ID, and this launches my instance. This launches my instance. Fine. As if now the state is pending, then it will be running. So it will take few seconds, almost a minute or two to be up and running. Okay. Now, the next question releases that how you can connect to this instance. What's a process to connect to this instance? See, the process is very simple. Is anyone of you using Mac OS? Anyone using Mac OS over here? Not sure? Okay, through iPad? See, on iPad it doesn't work, right? Because iPad uses iOS, but the MacBook, the iMac uses Mac OS, right? Ganesh, you're using that? Okay. See, guys, the thing is that why I asked you this question, because the process of connecting to this instance is different on Mac and on Windows machine. I'll show you from the Mac first, then I'll show you from the Windows perspective. For the Mac people, what you have to do is that, first of all, you just go to downloads because once you download the key pair, it gets downloaded on in the downloads folder on your computer. You drag and drop that on your desktop first, or anywhere where you think you can access it properly. And right click on rename, and make sure that you remove .txt from the end of it. because it should be in PEM format, not TXT format. You should use PEM, 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 right? Then you have to open your terminal. So I just opened the terminal in front of you right now. And the very first thing is that you have to go to your directory where the key is being saved. Type in cd desktop. Then once you type in the directory where your key is being saved, then you have to change the access rights of the key. That is chmod 400 and type the name of the key. So I just type the name of the key, Amazon Linux -kp.pem. chmod 400 and type the name of the key with PEM format. You're changing the access rights of the key. Press enter. Okay. I think I might have misspelled Amazon Linux. Okay, it's -sg. I'm sorry. So it is -sg. Done. Once you change the access rights of this key, then you run the following command to get the root access to this instance. SSH-i. Then you type the name of the key. I just copy and paste it from here. Let's copy it from here and paste it. Give a space. Then type in the username. EC2. Now, by default, the username of the Amazon Linux instance is EC2-user. Then you go back to the dashboard and you copy and paste either the public IP or the public DNS name of the instance. So I copy the public IP, go back and paste it. So the command is SSH-i Amazon Linux -sg.pem. That's the name of my key. Then the username, EC2-user. There's a default username of the Amazon Linux instance. The public DNS name or the public IP address of the computer. I'm sorry, instance, not the computer, instance. That you get, if you choose instance, under the description, you can find the public IP address or the public DNS name of your instance. Okay, so I press enter. It will give me a prompt. Are you sure you want to continue connecting? I would say yes. Press enter and I'm connected. I am connected. For example, I can run the command to install the updates. Sudo yum update -y. So I'm able to install the updates to this Linux instance. Fine. So that's how you could run a command to install the updates to the Amazon Linux instance. Now, the next thing that I will do is that I'll show you that how you make use of Windows, because majority of the people in this batch, they're using Windows. So this is from the Mac OS. What about the Windows one? For the Windows, you have to install a third-party software. Okay, so I go back to my Windows machine. I go back to my Windows 10 machine. And let me show you one thing. Basically, you have to download two main softwares, PuTTY and PuTTYGen. PuTTY and PuTTYGen. So let me show you. And also give you this link to download. If you just Google it, just type in PuTTY free download. Okay. And I just give you the link right now. You just allow me a few seconds. Here we go. Now this is the link that you can use to download the free software. The two softwares that you have to download, so under the alternative binary files, either you can install putty.exe, PuTTY, depending upon whether you're running a 32-bit or 64-bit version of Windows, PuTTY, or you can download PuTTYGen and PuTTYGen. You have to download both. You have to install both PuTTY and PuTTYGen. you have to install both the softwares. I just do that right in front of you. So because I'm using Windows 64-bit, I click on putty.exe and download this. Then I go to puttygen, click on puttygen.exe, 64-bit, and download this. Fine. Now, let me just go to my Mac and drag and drop that on my desktop. Let's go back to Windows. I go back to Windows right now, hit refresh, and you can see that Putty and puttygen are showing up. Now, the very first thing that you have to do is that you have to use puttygen to convert the PEM key to PPK key. Because you have to use putty to connect to the Linux instance. But the problem is, putty does not accept PEM key. It accepts PPK key. You have to go to puttygen and you have to convert the key extension from PEM to PPK. You open the puttygen, which stands for Putty Key Generator. And see the steps now. Go to File, and click on Load Private Key. Then I choose all files over here, and I go to my desktop, which I think I have to just go to the next, this PC, go to my desktop, and I choose or upload PEM key, right? And hit open. It successfully imports the entire key. Then I click on this option which says Save Private Key. You get this warning message, choose yes. And then I just type in, I choose Amazon. So I choose the same name, but now the extension of this key is PPK. What's that? It is PPK. Click on Save. And now you can see that the PPK key is showing up. The PPK key is showing up. This PPK key I'll upload to Putty to connect to my Linux instance from Windows. I go to Putty right now. I go to Putty. On Putty, I have to define the host name or the IP address. So I have to go back to the management console. Let me just go back to the management console. Either you copy the public IP address or the public DNS name of the instance. So I copy the public DNS name, go back and paste it. You don't have to change anything else over here. On the left hand side, you have some categories: session, terminal, window, connection. You expand connection. Under connection, we have a subcategory that's called SSH. Expand SSH. Under SSH, there's another category that's called AUTH. Connection, SSH, AUTH. Go to AUTH, that stands for authentication, and you have to browse and upload the private key. Browse it, upload the private key, the PPK key. You have to browse it, upload the PPK key. Press open. Press open. Press yes, and this opens the key, the window for you to log into Putty, through Putty. Login as, so that means in the login as, you have to just type in the username, EC2-user. Press enter, and you are connected using Putty. So you have to download Putty and puttygen. Puttygen is used to convert the key from PEM to PPK. Then you use the PPK key, upload it to Putty, and connect to the Linux instance from Windows using Putty. That's the difference. That's a whole and soul difference. Okay. Now, the next thing that comes in is that, what about Windows? I will quickly deploy a Windows instance and show you that how you connect to the Windows instance real quick. Because the steps are the same, with very few differences. I click on Launch Instance right now. This time I choose a Windows-based AMI, so I choose the Microsoft Windows Server 2019 base. Click Select. Then I choose the same instance type. I'll not change anything over here because the steps that are depicted in the Linux instance process is same. All the things are same. Click on Extract Storage. There's a 30 gig of storage. That's the difference. For Linux, you need at least 8. For Windows, you need at least 30 gig of storage. Click on Extract Tags. I can add a tag to it. Key, name, value, Windows, server, (2019). Click on Next Configure, Secure Group. Now this is where you have to do a major change. I create a new one. Just create a new Windows instance, Secure Group, Windows 2019 H3, and I can put something in the description. This security group will be assigned to my Windows 2019 server. Fine. I allow the RDP from my IP, remote desktop protocol, so that I'm the only one who can get the root access to this Windows instance. I click on Review and Launch. Launch. Now I can choose this option, choose an existing key pair, and I can choose the same key pair or the private key that I used for Linux. Because you can make use of the same private key to access any instance in the same region, whether it's a Linux or Windows instance. Okay, I can create a new one if we want to do that. We can just create a new one. But just for the sake of showing you, you can make use of the same key pair to access any of the instances, whether Linux or Windows, using the same key pair in the same region. So I choose this option, choose an existing key pair. I choose the same key pair, and I choose this option that I acknowledge that I have the copy of this key. I click on Launch Instances. This launches my Windows instance. I click on View Instances, and you can see that my Windows instance is up and running. Okay. Now, the question raises that how to connect. See, the process to connect via Windows, and I would say that the process to connect from Mac OS and Windows is different. Okay. First thing first, let me open my browser and log into my Windows right now so that I can connect to the AWS Admin Console. You hang on one second over here. So it's very, very important that you understand the differences between the Mac OS and the Windows sign-in, because the process is different for the Windows operating system and the Mac OS. So let me just really quick, I can just log into my management console through Windows. Okay, so I start with the Mac OS first. If you want to connect to a Windows instance from the Mac OS, you have to download a third-party software that's called the Microsoft Remote Desktop 10. It is free of cost that you can get from the App Store. You can get that from the App Store. If you just go to the App Store, just go there. If you just go to the App Store, you can look for Microsoft Remote Desktop 10. Okay, it's a free software. For the people using Mac, you have to download that on your computer. Okay. Now, once you download this free software for the Mac from the Mac, then you just go to Microsoft Remote Desktop, and you have to create a connection. To create a connection, you click on the plus sign on the top. You can see where my cursor is. There's a plus sign on the top, and click on Desktop. Click on desktop. Fine. Then you have to define the PC name. In the PC name, you either define the public IP address or the public DNS name of the instance. Public IP or the public DNS name of the instance. So I copy the public IP address in my case and I paste it in the PC name. User account. Click on add user account and define the username for the Windows instance. Now by default, the username is administrator with A in caps. Administrator. You can change that at the Windows level afterwards. The username is administrator. And what about the password? For the password, you have to go back to the management console. Go back to management console. Choose your Windows instance and click on connect on the top. Then it will ask you to get the password. This is the public DNS name. This is the username, administrator. Click on get password. And under the key pair path, choose a file. Then I go to the desktop. I choose my PEM key. Click on choose and click on decrypt password. Okay, decrypt password. I copy this password, go back to this console and paste it. Okay, I click add. Then I click on add once again. This creates a connection. Now I double click on this connection and it opens the RDP channel to my Windows instance. So right now you can see that it is initiating. So let's see. Okay. That means try one more time. Because I think the Windows instance is still launching. It takes a lot of time for the Windows instance to launch right now. I need to make sure that if I go to the security group, the inbound is allowed from my IP. Okay, let's do that one more time. I want to make sure that I have chosen the right IP address. Oh, I'm sorry. I picked the wrong IP address. I'm sorry about that. So let me just hit edit and change the IP address. So by mistake, I picked the Linux IP address. So if I double click on this thing right now, you will see that it's trying to connect. And from my Mac OS, I shall connect to the Microsoft Windows Server 2019. Fine. So you can see that I am connected. I am connected. So from Mac OS, I connected to my Microsoft Windows Server 2019 running in AWS. Okay. Now, what about if you're using the Windows operating system? If you're using Windows operating system, you open your management console, and I'm just going to the instance dashboard. Then I go to the running instances. I choose my Windows Server and click on connect. Then I click on download remote desktop file. Press open, click connect. It immediately will prompt me for the password. I can use the same password every time. So I can just click on get password, browse. I can browse for the same key, decrypt password, copy it, go back, paste it, press OK, press yes, and you will see that I am connected to my Microsoft Windows Server 2019. Fine. So that being said, this completes the entire process. This completes an entire process of instance. We discussed the concepts of instance launching, and then we saw that how to launch Linux and Windows instance.